We are starting Unit 4 in the Savas Realize. In this first lesson, we're going to be understanding equations and solutions for the equations. So you might remember when we were talking about expressions, we said that expressions do not have equal signs. Well, now we're looking at equations, and equations starts with EQAL, similar to the word equal. So equations do have equal signs. So we are going to determine if a value for a variable makes an equation true. So let's just say I tell you 3 plus n equals 5. Well, many of you might be able to tell me what n equals, but I'm going to tell you n equals 1. So now if I plug that in, I'm going to say 3 plus 1. Does that equal 5? Well, 3 plus 1 is 4, and 4 is not equal to 5. So we would say no solution. That was the quick version of this lesson. But now we're going to look at some word problems. We're going to look at some real world examples. And we're going to better understand why that is true. Yes, that how we just solved it is true, but why is it true? So let's look at this solve and discuss. Unit cubes are placed on a pan balance. If there are 3 cubes on one pan and 9 cubes on the other pan, what can you do to make the pans balance? Well, if you think of a balance beam, or you think of a balance scale, or you think of a seesaw, what does it mean to be balanced, right? If you think of a seesaw, and I'm tall, I get on one side, and someone who's smaller than me gets on the other side, is it going to stay balanced? No, I'm going to be going down, and the person who's smaller than me is going to be going up. So in order for something to be balanced, both sides have to be the same. Both sides have to be equal. So right now there's 3 cubes on one side and 9 cubes on the other. How can we make this balance? Well, let's start to move some cubes. I'm going to take a cube off, move it over here. Get rid of another cube, move it over here. So now I have 5 and I have 7. Going to get rid of another one and move another one up. Now I have 6 and 6. So then my balance would be equal. So now let's look at a word problem here. Example 1 says Jordan received a $15 gift card for phone apps. I'm sure you've received gift cards before, right? So you have a $15 gift card for some phone apps. He has used $4.50 of the value and wants to buy one more app to use up the balance. So that pretty much means he had $15. He's used $4.50 of it. Well, how much is left? How much is left on the gift card? Well, which app could he buy? So one way we can do this is to look at a model here. If I have a bar diagram, what is the total amount that Jordan received? Did Jordan receive $15 or $4.50? The total is the $15. And then one part of it would be the $4.50. So now I can represent the other part of this bar model with a variable. So pretty much what my bar model is telling me is that $4.50 plus X is going to equal $15. Okay, so I now want to figure out which of these phone apps, which of these values for X will equal $15. So we're going to have to start plugging in some. So I'm going to use blue for the recipes. So that's going to tell us that X will equal $9.50. You should be writing this. So let's rewrite our equation. 4.5, I'm going to get rid of the dollar signs, plus X is going to equal 15. Well, what did we say that X equals? We said here that X equals $9.50 or 9.5. So let's plug it in. 4.5 plus 9.5. We're saying, does that equal 15? Can he use up the rest of his money if he buys the recipes app? Well, let's get our calculators and let's add up this left side of the equals sign, because we want to see if the left part of the equation equals the right part of the equation. So 4.5 plus 9.5 is equal to $14. Well, is 14 equal to 15? No, it's not. So this is no solution, or not a solution. I'm just abbreviating. Next, we're going to do the sports app. The sports app is telling us that X equals $10.50. So again, I'm going to rewrite my equation. I have 4.5 plus X equals 15. So do I know what X equals? Yes, X equals my 10.5. So let's plug it in. 4.5. You should be doing all of this in your notebook just like I am. 4.5 plus 10.5. We're saying, does that equal 15? Well, use your calculator. 4.5 plus 10.5 equals 15. So 15 equals 15. Check. That is true. That is a solution. But just to be sure, let's do the last value here. The last value for the remote desktop says that X is equal to $12. So again, I'm rewriting my equation. If I rewrite my equation, that's going to minimize my mistakes. So 4.5 plus X is going to equal 15. Or it should equal. We're seeing if this is a solution. So will it equal? So let's plug it in. 4.5 plus 12. We're saying, does that equal 15? Well, 4.5 plus 12, I'm solving the left side of the equation here, is 16.5. 16.5 is not equal to 15. So again, I say no solution. So which app can he buy? He can buy the one for $10.50 to use the remaining amount on his gift card. So he would buy the sports app. So now equations can have all four operations in them. Equations can have addition, subtraction, multiplication, division. They can even have exponents and parentheses, but we're not going to be looking at those types of equations yet. But let's next look at an equation that has some multiplication. So in your notebook, I want you to write 14n is equal to 35. Okay, so 14n is equal to 35. First, they tell us that n equals 2. Okay, so we're going to do 14n is equal to 35. So we have to plug in n equals 2. What does it mean when I have a coefficient and a variable right next to each other? What operation is this 14n? 14n is 14 times. So I will have 14 times 2 is equal to 35. Let's evaluate that left side of the equation. 14 times 2 is 28. So is 28 equal to 35? Nope. No, that n equals 2 is not a solution. Okay, I want you to try the next one. The next one says that n equals 3. So you're going to write n equals 3. You're going to rewrite the equation. 14n equals 35. We're going to take that value for n and plug it in. When you plug it in, is that a solution or not a solution? Well, we should have 14 times 3. Does that equal 35? 14 times 3 will be 42. 42 does not equal 35, so you should have got no solution. So now I want you to try n equals 3.5. Again, rewrite the equation, plug it in, and I want you to do n equals 4. And I want you to tell me if either of these are a solution or if there's no solution, or if they are not a solution. So the answer to this question is that none of these values for n is a solution. Look at how nice and neat I showed all my work here. I did n equals 3.5. I plugged it in. I solved the left side. I got 49 does not equal 35. You should have this in your notebook. Nice and neat. I can clearly see my work of what value I plugged in for n, that I multiplied, and I proved why it is not a solution. Well, n equals 4. Well, 14 times 4 is 56. 56 does not equal 35. Let's try one last problem. We are going to do number 8, so you can start copying that question into your notebook. I want to know which of those values for m is a solution to the equation. So if we have 4 is equal to 36 divided by m, and I tell you that m equals 4, m equals 6, m equals 8, and m equals 9. Which of these are a solution to the equation? Please make sure that you are showing all of your work in your notebook, because you never know, tomorrow Miss Hatz and I may just look to see your work from tonight's homework. Okay, so make sure that you're showing all of your work in your notebook to solve this question.